And welcome to our DIY face tracking meet. We are the developers behind Project Babble. You might have heard of us in VR chat, and we are super excited to be here at Virality talking about our project today. My name is Hiatus. To my right is...
Rams the Generic.
I'm Arrow.
And I'm Summer. Hi.
So the way the speech is going to work is we're each going to have maybe like 8-10 minute segments talking about one cool thing we did on the project, right? Or a theme, what we're working on. Additionally as well, because it still is the beginning of the presentation, if you can invite your friends here, we're looking to have a big old audience. We'd love to give this presentation to as many people as possible. So don't be shy. Let's see those babblers in action. And to get back to what we're actually going to be talking about, I work mainly on the front end, so things like the VFC face tracking module, the documentation, that kind of stuff. What do you work on, Mr. Generic?
I do a lot of work on the data sets for training the models, the hardware in which you're actually going to use the models with, and I also do a lot of testing for these two AI goobers.
Nice. How about you, Arrow?
I do a lot of research and experimentation with AI stuff, trying to figure out how we can improve the technology.
Hi, yeah, and I'm Summer. I'm the founder of the project, and I do a lot of research and development for AI. I make the project run smoothly, all the sorts of middle management things that have to happen to make everything run.
Splendid. And I believe this next slide is just rehashing what we are going to talk about. So I will advance to the next slide here. Summer, get to the podium. Kick us off.
Hi, everyone. As I stated before, I'm the founder of the project. Let's continue. I'll be kind of talking about the history of Project Babble, why we chose to do certain things, what the sort of timeline is of how Project Babble came to be, and kind of maybe a little bit what we're going to the future, but these guys will talk way more about that than I will. So my prior work was EyeTrackVR. If you don't know what that is DIY eye tracking in any VR headset. You could just mod it in and it works. Right. This was my prior work about maybe 5 months before I started Babble. I was working on the EyeTrackVR team, working on EyeTrackVR, and while I was working on Babble, I also continued to work on EyeTrackVR for some time. I like AI stuff. My professional education is not in AI research, but it later did become AI research, and I extensively did it for both Babble, EyeTrackVR, and just my job in general. Some guy a really long time ago, I don't remember their name, told me that you couldn't do face tracking with a single camera because back then the only facial tracker was the Vive facial tracker, and that had 2 cameras on it. And so I set out to prove them wrong because that is something that we tend to do a lot. And I learned from the open source nature of AI research, and that inspired me to make Project Babble originally open source. Later that changed due to certain factors. Right now we're source first, which is where the source is available, but we have a commercially restricted license. But if you contact us, you can get a commercial license easily. So we ended up not becoming open source, but in the beginning we were open source. And AI research and the way that AI research is distributed really inspired us to do that. Moving on. So to begin, before Babble, there was the Vive facial tracker, which you can see there. The Vive facial tracker is $150. It is universal. It was released in 2021, so about 4 years ago. Tracks most expressions pretty well, and it just worked, if you will. But it had a handful of things that were not so great about it. Right. First off, the camera placement is fairly picky, even on the Vive facial tracker. So you have to be careful. If you're not on a Vive headset, it tends to work a lot better. If you're on a Vive headset, it tends to work a lot better, and if you're not, it tends to work worse. And there's poor tongue tracking overall with the Vive facial tracker. People experience that a lot. So, and the other issue is that it's a black box, and so you don't know how your data is being processed, right? We really believe in data security, and I'll bring that up later, is that we believe that your data should be known about how it traverses through a system, especially when that system incorporates a black box like a neural network like we use. So having an open sort of system that works for everybody is really important. And then later, of course, Vive had some other attempts on their facial tracking thing, and it shifted away from their philosophy of Vive facial tracker being universal to them locking down their platform to specific headsets. They realized that while the Vive facial tracker does sell well, or did sell at the time well, now it doesn't sell any more headsets. It just sells Vive facial trackers, and they wanted to sell headsets. So they started manipulating their own facial tracking technology to only work on certain headsets, even though it could totally work on everyone's headset, as we saw before. So we also were very much against this idea that they should start locking this down. But it did also prove that you can do face tracking with a single camera, because all these new devices only had a single camera. But they kept the same black box approach where you couldn't see where your data was going throughout the system, and that was also a privacy issue, especially with something as sensitive as your face. So, that's something that we really focus on in Project Babble, is making sure that the source code is available and known so that you can see exactly how your data is traversing through that system. Our hardware philosophy is totally open. We want there to be open hardware. We want there to be weird hardware. We want there to be fun hardware. We want there to be hardware in weird and fun different ways. So we chose the ESP32 based on its availability, pricing, its accessibility, its easy pipeline to actually work on and make firmware for. It was super duper easy. So we decided to use the ESP32 as our hardware platform. We had other candidates in the past, different types of UVC cameras, different other kinds of full-on, even SBCs were candidates in the past. But the ESP32, we kind of settled down as a more generalized approach to providing open hardware, because it was easy and it was also available and the pipeline was known. And we also had to strive for universal compatibility. This is a really big one, right? We needed Babble to work on any VR headset. It needs to work on all sorts of different environments, and has to work with the Vive, the Quest, all of them, right? We did this purely to flex on Vive because of their movement from this sort of more generalized thing, and also because we really care about making sure our community has access to face tracking technology in the open, right? And we did a bunch of experiment with mounts, right? Every headset is different. Maybe besides the Quest headsets, but every headset is super duper different in terms of their shape. So every single mount that we design it with a huge focus on their shape, on how far they are away from your face, right? Where the camera is relatively to that. So overall, we need to make sure that it works on any headset. Okay, moving on here. Rames, this is you.
Ah, that's me. Alrighty. Howdy. I am Rames the Generic, like we mentioned in our introductions. Yeah, like I said before, I work on the datasets and hardware, and that's exactly what I'm going to be going over today. So, some things to get down, and as you might expect, if you were to try and make your own face tracker, the better your training data, the better face tracking you're going to have. That might have been obvious already, but this data set contains everything that a face tracking model can potentially learn. So different face shapes, all those different lighting conditions, it needs to be able to take into account all of these different things. In our case, our data set is comprised of a bunch of images with metadata, with metadata explaining what each blend shape is in that image. And yeah, like I said, since it contains everything the model can learn, it has to represent its intended use case. You could have one of the greatest algorithms ever known to man. However, if you give it garbage data, you will get garbage data out. There's just no getting around that fact. So let's first take a look at some existing data sets, because we ended up having to create our own, but why didn't we just use ones that are out on the web already? Well, there's plenty that are out there. However, none of them contain any of the correct information that we actually need in order to train a good face tracking model. Since blend shapes are kind of the standard way of conveying facial expressions, in case you don't know what they are, if you notice your mouth fly seems to move whenever you talk, those are different blend shapes that are triggered based on the different sounds you make. What we need are blend shapes for different face shapes. And currently, none of those datasets out there are available, or they're locked behind certain kinds of paywalls, or they are incredibly limited in what we're able to actually do with them. So came the task to actually create our own. We we obviously needed a data set that would include images of specifically the lower faces, because previous data sets all in the past were typically included the full face, and the images in them were typically taken from like a selfie camera sort of distance. So not a camera that's close up, like mounted underneath the headset. Like I said, yeah, we need a close-up high field of view image because we obviously don't want to have a camera that's like 6 feet off away from your headset, because I don't think you want a roller hanging off of there. And since we're having to make it from scratch, we need to make sure we have a huge variety of faces represented. So skin tone, lighting, face shape, different room lighting, all that kind of stuff, that has to be included in this data set. And oh yeah, of course, we also need blend shapes. No key points, no image segmentation masks, blend shapes. So I guess before we had our synthetic data set, there was Summer's proof of concept that he made. This data set is what trained the model that Summer used in his original demo video that he recorded years back. And
Yes.
the original data set for this was created using existing tracking solutions at the time. So in this case, just an iPhone with the Face ID sensors. And yeah, that's about all the data he had for that.
Yeah, my crappy
could
tech demo.
For that crappy tech demo. It could also take bifacial tracker data, but no one contributed at the time, so it didn't really make it in. Anyways, as you can imagine, with it being a first-gen attempt, it came with a whole slew of issues. Firstly, since he has to sit there and record images with his iPhone, the amount of data you can get is incredibly limited. You know, if you're recording at 60 FPS, that's going to take some time to reach a good amount. So for this original model, he only used like a few thousand frames total. And additionally,
yeah, it was like 5,000.
Yeah. Additionally, these images are not representative of like the actual use case of a camera being on a headset. Like I said before, all of those previous data sets were taken from the perspective of like a selfie camera. So was ARKit. It was taken from the perspective of a selfie camera. So if you try to get it up close, it's not going to work. So you're forced to stick with that selfie camera type deal. And as you can imagine, the end result of all that was very mediocre. Sad cat. And so one day I was kind of sitting in one of my SolidWorks classes, just bored. Came across this project through some rumors I heard through the grapevine. I heard there was a need for some data. I had a little itty bitty bit of Blender knowledge. I was like, okay, know it. Sure, I'll take a crack at it. And I slapped together this thing. It was made entirely using free assets, so like free face models, free textures, free headsets. If I had to spend a dime on it, I did not buy it because I was a broke college student. We were all broke college students. We couldn't afford assets. So, yeah, the end goal, when it was designed, we tried to make it as diverse as possible, given these very severe limitations. So, you know, we had some randomized face shapes, had some randomized textures. We had some of all that, and of course, randomized blend shapes. And I will say the models trained on this were not great. However, what it did do great was its ability to make a model generalize. You know how I said previously the model Summer trained, how the end result was just mediocre at best? Well, that best was when it was Summer using it. If someone else tried to use it, it would most of the time flat out not work at all. With the results of this model, yes, the end result was still mediocre at best. However, it was consistent across most people, which was a huge step at the time, making it work from one person to several. And so given the success we saw with this, we of course iterated on this, and we iterated on this for about 2 years in total. So improving things like I said before, the face shapes, skin textures, camera positioning, lighting, the amount of different meshes used, swapping out assets with different ones, and up until Babble 2.0.5, this is primarily how we increase tracking quality, through just improving this data set. And then one day, as we were like messing around trying to improve the synthetic data set again, we started to hit a plateau a little bit as we started to reach the end of my Blender skills. Like I said, I know a little bit, but like I wouldn't exactly bank on getting hired at Pixar. But yeah, so we started playing around with different ideas to, okay, how can we continue to improve the tracking quality? So we're like, okay, why don't we just include real images? They're in domain. They're representative of where we're going to use it. Let's try it. And the end result was a dramatic increase in tracking quality. As you can say here, it serves as a really great enhancement to synthetic data. Like we saw with the original summer data set, like around 5,000 frames isn't enough to truly make a good model, but when you combine it with the synthetic data, all of a sudden it just works. You smile and you're smiling. Like there's the amount of calibration and other post-processing you have to do to get that sort of generalized result to match your face is significantly less with this. And as a fun fact, real training data only makes up 0.5% of our current production data set, which also makes it like very potent.
Yeah.
Yeah. However, as we started to accept user data submissions, we began to realize that it was also a double-edged sword. So, although I said it's a great enhancement to synthetic training data, it still requires good synthetic training data. So, if someone does not track well or at all with synthetic data, they will also kind of have a bad time, even with some real data. Yes, some expressions will be improved, such like especially those that were shown in the examples that we provided. However, this is due to the model overfitting, which means that like if a model, which means if you were to do something, so if the synthetic data did not work too well on you and you tried to do something that was a bit different than what an example was, the model would try to snap to the nearest example, which isn't what you want to do. And so, and to be fair, and with the results we saw from that, it began to shed light on the flaws of our current synthetic data. Yeah, it began to show flaws in our current synthetic data. So some of the common edge cases we saw, like strange face shapes, facial hair, camera images, like weird camera images, all the stuff I mentioned before, we found, okay, we need to improve these in the synthetic data set, and so we finally got to work. Given that we began to start shipping our Babble hardware units, we finally had a little bit of dosh on hand that we could put towards improving this. So, like with some of the cash we had, we went ahead and hired artists to go ahead and create us some proper photorealistic assets that we could use for our new data set. They of course improved upon everything that we had previously. So much more examples of facial hair, much more skin tones, much more face shapes. Everything was better. We even have troll face up on there. Additionally, with these new improvements we got, they were also much faster to render. Because since we switched from Blender to a more real-time engine, we were able to generate more examples of like these edge cases, which of course means better or more representation of these not so performant like cases. And yeah, additionally, when we're able to generate millions of frames, our time frame in which we have to render before we can actually start testing is much shorter. So we can iterate and test like different randomization algorithms and other sort of things much faster. Another thing is we designed it with like some more specific hardware in mind. Why did we do this? Because in the past, hardware was not standardized whatsoever. And as you can see by the huge variety of setups we have here, just from us testing, this created a number of problems. And although past datasets were designed to be as diverse as possible, they could not. They just couldn't deal with that variety. So we sat down and decided.
Sorry.
Oh.
They could not.
They could not. He's right. They could not. So we realized, okay, we said any camera in the past, but we need to narrow our scope a little bit. And so we decided, okay, you need to have some form of illumination. It needs to be a head-on view, and of course, it needs to be a reasonable distance from the face. So like, not touching your lips, you know, that sort of things. And at the time, there was no one selling some kind of DIY kit or anything. So we decided, fine, we'll do it. And so we began designing a board that met all of our previous requirements and could be something that someone could just toss in a case and slap it on their headset. And of course, just like most prototypes, it did not work. However, if you've seen that second Eldritch Horror image, it works now. The issue turned out to just be a bit poor regulator component, and it's not the last time we'll see that. And also during that process, we found a bug in OpenIRS, so we were able to get that fixed for everyone. So that's fun, I guess. Yeah. So of course, when we finally found the fault, we of course revised it a bit, and it's also around this time where we went to open source in 2024. These boards arrived on my doorstep the day before I had to take off, so I was able to take them with me. And push came to shove, our DIY setup there broke, so we were forced to actually demo these on the showroom floor. And from letting people try these out, like just on a wide variety of people, we found that the setup actually worked very well and gave us a nice little morale boost. And of course, with all that stuff in mind, and of course, with all that good stuff, had to make a couple more iterations of stuff, you know, getting it ready to actually be produced. And, you know, went on, made enclosures, mounting hardware, all that stuff is available to be downloaded, used by anyone. We went ahead and tested them, went ahead and sent it off to a few testers. They came back okay. And so with the green light, we passed it off to mass production. Month or two later, everything started arriving at the doorstep, and quite a bit of stuff, you know. But you know, on assembly day, I think DFG wrote down "Oh boy." That is a very excellent description of it. Every board came back with a defective part, all 550 of them. Take a wild guess at what it was. Regulators. Good old voltage regulators, right? But that's because the factory put it on they put on the completely wrong part. So I was saying that. Anyways, I diagnosed and fixed it. Just replaced all 500 regs. That was fun, I guess. And we finally began shipping units. Summer came over for a week. We just grinded those out. Yeah, we did nothing but assemble boards all week, and you didn't get to explore the town at all. We were just sending those out. And we learned a lot during that process. And additionally, I want to give a big thanks to my dad for letting me turn the entire upstairs of his house into a sweatshop for a few months. So thanks for that. And finally, since that pretty much leaves us to where we're at now, let's start to talk about a few things for the future. As these mounting hardwares have become more standardized and consistent, we've pretty much solved the issue of bad setups for the most part. However, some of these edge cases that I mentioned previously still persisted. Since we saw real data can potentially solve some of these issues, but we're limited by the fixed sequences we had, we decided, okay, we need some tooling to label real images. And so, we realized the outputs of our current model that we're testing are good enough to serve as a baseline for a skilled animator to go in and, I guess, correct them or something. Potentially we can solve these cases with some proper tooling to label real data in a way that's not going to make the model overfit. And I think that's all I have here for you today. Mr. Arrow, would you like to take the stage?
I suppose that's me now.
All right.
Well,
please.
I will get straight into it. You were just mentioning the importance of the accuracy of real data labels. And one thing that I've worked on here for us is a tool for Blender that actually, well, first let me explain the benefit of it is. Essentially, when you have real data, for example, if you have a video uploaded where we know the user opens their mouth in this video, and we know in the middle of the video they have their mouth open, and at the beginning and in the end they have their mouth closed, we could label that and create an animation curve in Blender, and that might roughly approximate the actual movements that they've made. However, the amount of error that's introduced from just using a direct animation curve there is enough to cause issues with the real data accuracy. And so we created a tool that essentially, given the knowledge that we know in the middle of the video they have their mouth open, and at the beginning, at the end they have it closed, it can train a small model and contrast those examples and then build a proper animation curve that's properly locked to their movements, as you can see in the bottom here. And that tool hopefully will become more useful in the future as we bring in more real label data to improve the data set. Another thing that I've done in the past, we touched on the Vive stuff a bit. One thing that was really limited in is that you couldn't really expand upon it or train new expressions, or if it didn't work well on your face, basically that's it. It's a black box. You don't have any recourse to improve it. One thing that I did early on was I figured out a way to train new data into this model by adding new layers on top and improve things like beard and other facial expressions that weren't there initially. And I was able to take that knowledge and apply it to Babble stuff. This is more about the what I was discussing earlier, the tooling. You can see subject that there was a very strange texture issue that happened, but essentially that would animate with the video. I'm going to skip ahead here. Another thing that I've worked on with the knowledge that I gained through what I mentioned earlier with the Vive stuff, I learned a lot about how this face tracking AS stuff works low level and low down. And one thing that Vive did get right is they use a very small, what's called a model, the actual AI model is very small in memory, so it takes very little compute resources to actually run it on your computer, and basically it won't lag your computer if you run it. One thing that we'd like to do is improve upon our own model size so that we can improve the performance of the app, and so that it doesn't have so much of an impact when you're doing face tracking. We've tried a bunch of different models. I won't go into detail about specifics, but there's a lot of research going on there under the hood to improve the performance. And one thing that we were able to use that for already is we've taken a lot of that knowledge and built it into a new model that we're building, which is for eye tracking. So essentially we've built a new solution for eye tracking. DFG will touch on it a little bit more later, but essentially it creates an overlay where it follows you through a few steps and you follow a calibration process, and that collects some data just specifically for your face, your eyes, well, not just for your eyes, your upper face. And then it trains a model specifically just on that. So essentially we don't need to go out and build all this data setting that we discussed earlier. We can hopefully get a solution out there early that works for everybody. And we hope to track more than just gaze. We want to have upper face tracking, the sort of tracking that you'd expect from a headset that has full eye tracking, like widen and squeeze in the upper brow expressions and whatnot. And to quickly touch on the research I mentioned earlier with model size reduction, this graph on the bottom part of this slide, one way that you can, if you have, Summer said that with face tracking, we do it with just one camera. Well, with eye tracking, you kind of need a camera for each, unless, it's much easier if you have a camera for each eye. And the problem with that is if you feed both cameras into this AI, it really increases the compute cost if you just put the images side by side like you would intuitively. But if you stack them channel-wise, and that's an image has color channels like red, green, and blue to represent it. If you stack the images channel-wise, we found that you get very similar performance, but the actual compute cost, how much it lags your computer, is way lower. So that's one thing that we hopefully will be able to bring into our other models, but we're applying it to our eye tracking solution at the moment, and it seems to be showing promise. And yeah, this is going into what I was just discussing. However, I think that will be Mr. Hiatus now.
Thank you. All right. Hello, everybody. If you have stuck it out this long, thank you very much. As a recap, I'm Hiatus, that guy. And in addition to the BRC face tracking module, I'm also working on the new Babble app, which is the subject of my presentation. So, a brief history. First off, the Babble app was originally an offshoot of the current EyeTrackVR app. 2 years ago, Summer, it's like, I'm gonna make this do face tracking, and that's why they kind of look the same, basically.
Yes.
Right. Now, my note here, as such, the apps look visually the same. At the same time, we also grandfathered in the technical debt of the project. So as we started to add new features, right? oh, we're going to add like support for 12 languages. Oh, we're going to add support for blah, blah, blah. There were problems. There were many problems. The number one was packaging, right? So every time we have a new build, we want to make an installer, we want to throw one file at you and have fun. But let's say we wanted to upgrade our desktop notifications. We tried switching out this one package. It busted things for a solid week, at which point it was just easier to remove it outright. There's also a lack of mobile support. According to the Steam hardware survey, an overwhelming majority of people experience VR chat on a Quest standalone headset. A computer's expensive, unwieldy to set up, and the Quest is just easier in comparison. Additionally, there was also the general, lack of documentation, performance issues. It was unintuitive, and you can make the comparison looks like a Windows 95 application. Taking a look at my speaker notes here. I guess talking about the lack of mobile support. Originally, there was also I'll call it a first-party lack of macOS and Linux support. I was able to add that after the fact, but it really goes to show, right? Like, if we wanted to do more, there needed to be change. So we set out to create a new one that had all of the good of the existing, Python app, right? Had all the languages. It was faster. It was smoother. It was all that stuff, right? It needed to be scalable. Mobile support. It needed to look nice. People like a good GUI. So I've been cooking up this bad boy. Say hello to Babylonia. This name took forever to decide on. It is a successor to our existing Babble app that comes with a, per eye tracking and face tracking, comes with a VR calibration overlay for your expressions, and you can also flash your firmware from within the app. So if I go to the next page, you can see the home outview of this. And there were a couple sources of friction with our existing app, right? If I go back a couple of slides, take a look at the top right image over here. That's the home screen. Functionally, it works. But just by looking at it, can you tell me, just by looking at it, do you know what it does? And that was a real problem source of friction for our users. So here, I've tried to make this as clear and unambiguous as possible. Start, stop, tracking for tracking, cropping for cropping, and you have your settings. That's all hidden away from you. Additionally, another source of friction was our firmware flashing within the app as well. I'll get to that here in a second. But in the top right, you have the VR calibration overlay. You saw Arrow's thing, which was amazing, honestly. I cannot wait for you all to have it. But another major source of friction was our onboarding. You see, it's difficult enough to give users a very, complicated app without some kind of prior introduction. And what we tried to do was, okay, it's your first time using the app. Where's everything? How do I use it? So we set out to eliminate that kind of source of friction as well. Moving on. We also have calibration. We do have per expression calibration in our Python app. It's pretty good, but instead of throwing every single expression at the user all at once, instead we compartmentalize these based on their name, prefix, and category. So a cheek expression will fall in the cheek category. Yep. And here's what, an expanded section looks like. One thing I do want to add is the current expression in the slider, so it makes it very nice to see what expression you're making. All right, now let me get the firmware. So this was a big one. You see, when many users received the 300, 500, however many Babble apps that Rames and Summer received here, some of them wanted to use it in wireless. So our Babble trackers can be used wired, plugged into the headset, or wireless. Let's say you're a PC VR user with a standalone Quest system. Well, you can use Babble wirelessly. But to get that, you need to write what's called firmware to it. And to do that, you have to download another app and figure out how to use that. Nobody wins. So we set out to add firmware flashing within the new Babble app. I have optimized the user experience to take less than 10 clicks or 1 minute, whichever is less for you. This is what a wired setup looks like. You select your tracker, you select the firmware in question with a suggestion, helpful suggestion. And this is what the wireless page looks like. Ooh, fancy. Emoji. Right. Anyways, the settings page, I won't take you through this. We've been translated into 12 plus language, like I said. Thank you to the people in our crowd. We have GPU support out the wazoo, and the current performance of the application is on par, if not better, than our existing Python application. Excuse me. Let's see, nothing in my notes here. That is splendid. Oh, yeah. All right, next slide. Dark mode! Oh my gosh. You didn't think this thing would have a dark mode. I've been only feeding you light mode pictures. But no, another thing about this as well is the theme and accessibility, right? In the bottom left, you can see me experimenting with a Windows 7 design because why not? Fruit of your arrow is the popular thing that crams my Reddit feed. This also gives rise to like high contrast feeds. So let's say you need big block letters because you're in VR, big buttons because, pointer is tricky to use. You got that as well. But none of this is hypothetical, right? So up until this point, we were talking about, our eye tracking solution, our face tracking solution. And I want to be clear. This is the source for this is available for download. We don't have a release for it just yet, but Summer's a living proof over here. And we're confident that we can take this and deliver something I don't want to make any promises. By the end of the week, I want to say. And whatever. We're like stupid close. He has his eyeballs. I just need to take his eyeballs and shove them in my app. You also need VRC face tracking for it to work with Babylonia, so give that a download as well. And that concludes our presentation. I've left up some QR codes for our Babble Discord, our store if you're interested in purchasing a Babble tracker through our first-party partner PyShock, as well as our documentation if you would like to DIY your own. With that, I yield my time to the floor and would be more than eager to answer any incoming questions.
We've got so many questions.
Got quite a
first
few.
thing real quick. First thing I do want to say real quick is Rames has the eye tracking running like right now with eyelid and eyebrow
too?
support.
Hello?
Yeah, no, he does more than I do. I don't have it running right now because my Beyond is acting a little funky. But he's got eyebrows and eyelids. Rames, do things. Go do eye things. Look at you. Look at him doing the eye things. It's
Eye doing
crazy.
eyeballs, yeah.
Boss,
It's crazy.
reveal.
No way.
Incredible.
All right.
It's
Um,
he's got Babble with that too.
So, anyways, we have the QA section here on the Discord pulled up. If you're an audience member and
Hello
you'd
there.
like to, yes.
Hi.
Sorry to jump scare you. I'm actually here to read the questions for you.
Oh, perfect.
Right.
Awesome.
Let's do it.
Let's see. I've got a question here from Mitski asking, what is the stance on using a standard webcam with Babble? If one is suitable, do you have any camera recommendations?
Yeah.
Okay,
I mean, yeah.
Sorry.
Yeah.
Okay, let's
Should I
go left
answer?
to right. Let's go left
Okay.
to right. Okay, yeah.
So yes, it will work with a webcam. The one thing is you have to have good lighting. We started sort of making our models more sort of generalized onto our existing ESP hardware because webcams are so many of them. They're all running at different resolutions, at different kinds of lighting and gain, and the cameras have different properties. So we sort of try to limit the scope a little bit, as Rames was saying earlier in his slides. So webcams will work. You can make it work. Just you have to set it up properly, right? With Babble, the more work you put into the system, the more you're going to get out of it, right? So make sure you do a good setup and don't just do it jankily. If you're going to do it, just buy the $30 worth of hardware and use an ESP32 and some simple IR LEDs and follow the docs, and you can get a good Babble tracker going.
Okay,
for
but
about the same amount of effort. But it will work. It'll work. It just won't be that good.
I'm encouraging you to try. Listen, it's with web cameras, it's literally a dice roll. I'll leave it at that. But yeah, you're welcome to try.
The dogs.
The dogs.
All right, thank you for answering that one. I've got another question here from Nami asking, does your training data include facial hair, beards, and bushy mustaches?
Yes. we have
Absolutely.
millions of bushy mustaches and mangy man beards in our training sets.
Maggie.
Yeah.
Yeah, but yes.
Oh, sorry, no, keep going. If you had more to say.
Well, how do I put this right? That's one thing that definitely separates us from, say, the Pico 4 Enterprise and the Quest Pro. We have a robust model that actually works on facial hair, and it is proven to work on facial hair. Granted, these are our release candidates, so nothing official just yet, but you can download and use it, so yes.
When I used the Vive tracker, I had to shave my face for it to work, so that's great to hear.
Yeah.
I've got another question here from Opabina asking, any plans for pairing with ETVR to create buyable sets for complete full face and eye tracking?
Maybe.
Maybe.
Hardware is hard, as it implies in the name. So maybe.
Yeah. Question here from Raptor asking, there was talk about creating your own MIPI CSI based camera module. What can we expect in that regard in the future?
While nothing is set in stone yet, the idea is to hopefully be MIPI CSI to UVC. That's kind of the plan. Use some kind of USB to MIPI chip thingamabob.
We've been really busy. We've been very busy with the app and whatnot. We're getting to it.
Yeah.
It's in the roadmap, but we've been really busy. We'll get there.
We'll get there.
But question for Firon, actually. I'm seeing people ask if I can post a link to the Discord in the QA chat. With your permission, may I do that?
Yeah, absolutely.
Yeah.
Feel free to drop
alright.
links in there. If you want to share the slide or link to your Discord or anything like that, you're totally welcome to.
I'll get everything up there, actually. Right. Oh.
I have a question here from Seldom Needy. Which real-time rendering engine did you switch to for faster synthetic data generation?
You can answer Arrow. You can answer Arrow.
We switched to Unreal, actually.
Ah.
Unreal. Crazy.
Unreal.
It's Unreal.
Good.
Unreal is
UE5
fast. UE5 UE5 slop.
Getting the
Let's see. I have another question here from Sent from Space. What data augmentation techniques do you make use of for synthetic data sets? For example, do you simulate a dirty lens by blurring the image?
Yes. We use so many. There's
Yep.
rotation, translation, blur, noise, crop in. So we do a center crop. So you take the center of the image and then you crop into that as the new image. So many augmentations that we have to tune. Fisheye distortion,
JPEG
different
compression.
weird JPEG compression for Wi-Fi. So many. There's so much research that's gone into just making augmentations. So yeah, that's a good question. We do a lot.
That's fascinating. Thank you so much. Let's see. Question here from Sawtax asking, have you tried to bring the tracking model or part of it onto the microcontroller using something like TinyML, for example?
Well, part of the reason why we're doing research into shrinking the model is we can't do that yet, but shrinking the model might open up doors like that.
If I may, so currently Babylonia can run on an Android device, but because it uses the same desktop-sized model, the same requirement is there. But until again it gets smaller, you're going to have subpar performance. So on a PC, it might be the frame rate of your camera 120 FPS, but I've had instances where it's closer to 20 FPS because it's just running on a smartphone.
Right. So yeah, and by Android we also mean Quest, by the way, if that wasn't clear.
Right. Sorry.
That was the bigger one, is that it does run on Quest. This app does run on Quest. It runs okay, but it's not as good as a PC right now. But as Era said, we're working towards making models smaller so that they run better.
Yeah, so and again, this is a bit of a tangent, but one thing that I want to do is I want to be able to, I'm holding my phone right now, I want to be able to run Babble on your phone. You could just set your phone down, and then you're able to have that act as a co-processor to your headset. So while your cameras talk wirelessly to Babble on your phone, it talks back to the headset. So that way, if you're on standalone, you still have the full facial expressivity without any additional anything.
All right. Thank you so much. Got a question here from Shine asking, is there a tutorial for building a complete face tracker end to end? That's with all the components and the scheme of connections.
Let me pull it up.
I would say there is. It's in it's written form. There's no video form yet.
As of right now,
there should
it
really
is
be
all
a
in written
video
form.
If anyone wants to make it, I challenge you. Go make one. There's so many people here who have made Babble trackers DIY. Any of you could make a video on it. It's super easy. I'm sure you'd get lots of views if you cared about that. But you could totally do it. We're also going to try doing it. Like I said, though, we have so much on our roadmap right now. But we will hopefully get to it eventually. But yes.
right.
posted our YouTube
I've got a
channel.
question here from Chimera Dev. Are you going to start supporting molds and mobile support for the Pico headsets?
Yeah, it works on
So-
Android.
Yeah, so I don't want to get too in the weeds here because I want to, keep this as general as possible. But while, how do I put this? The Quest, let's see, all Quest 3s are Androids, but not all Androids are Quest 3s. Likewise, all Pico 4s are Androids, but not all Androids are Pico 4s. So if we make something for Android, like the same thing for your phone, in theory, it should run on the Pico, on the Quest, just like any other Android app, if that makes sense. I hope that answers your question.
I think that does. Thank you.
Okay.
Actually, really interesting question here from Schmoopy Rue, asking, do glasses impact the tracking of the eyes?
No.
No,
That was the biggest one, actually. It won't. Hell, you can only so you see ETVR before only had 4 LEDs. We know for a fact that you can run our new eye tracking with only 2. You can have such poor camera quality and it working. It's crazy.
It is kind of ridiculous how bad it can be.
Yeah.
I think that's a testament to the new model's quality.
If I may, one thing about the Babble store, right? So currently the Babble trackers go for right now about 100 USD. However, we do want to get that price down. Like we know we can
Eventually.
Yeah,
No promises.
I mean, right now, yeah, it's a little tricky right now, but for reasons, but we'll get there. Like, yes.
All right. Question here from Eric Bazinga, and I think you may have already answered this, but is this presentation available for later viewing?
I think Ava's recording it for us. Well, Ava's recording it for us, so we'll just post the video there.
Well, I can also get like
Right.
the PDF or whatever.
Well, I
That's
think they
the
might have
thing.
been asking about the slide deck itself.
Yeah.
Oh, the slide deck. Yeah, we can make it
Yeah.
public too. Why not?
Yeah, let me grab it.
Yeah. I think folks would super appreciate that. Let's see. A question here from Bardic. What headsets would you recommend for Babel when you're a Linux user?
Good question.
What works with Wyvern? Stuff that works with Wyvern probably.
So, hello, I'm on Linux right now. I might be qualified to answer that question. So, really, any headset that works with Linux, like off the top of my head, I know the Vive, the Valve Index, the Vive Pro, they do work. If you want to get a little experimental, you could try using ALVR with a Quest 2, possibly Quest Pro. I also wrote VRC face tracking in Babylonia, so you would be able to use the existing modules to get EyeTrackVR, Babble, as well as those headsets to work as well. There is also the Linux VR Adventures Wiki, which has a comprehensive outline of compatible and incompatible headsets.
The Linux crew is doing a lot of really cool things right now. They have really done a lot of work to make things awesome right now for Linux and VR. So if you do have the time, I recommend you try it. It's awesome.
All right. Thank you for answering that. Let's see. We've got a question here from Vel. With the Beyond 2E coming out, and if you're not familiar, that's a headset that will have eye tracking built in. I may be how compatible would the Babble mouth tracker be with the built-in eye tracker? How would the setup be like for someone new to face tracking?
I am using the Beyond 2E right now. It is really on. It is on our radar. I will say. I am wearing one. Now the eye tracking isn't on right now. I had some issues. It's a prototype unit. Blah 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 blah. But I am wearing it right now. So it's on the roadmap. It's 100% something that we are looking into for like full compatibility with our stuff.
Wonderful. Interesting question here from LSA. You mentioned security questions early on. Could you expand on what that means for your project?
Yeah, so we care a lot about how data flows inside of the system, right? So right now it's fairly simple, right? Your face tracking data flows through the application, goes to the model generates some output, and it outputs that data, and then the frame is deleted, right? What we care about really is just making sure that your data isn't saved anywhere. There's no like weird frames being cached in your Windows computer that some attacker can get to at some point. Right, we care a lot about making sure that your data is entirely on your local system. and we want to make sure that it stays that way. And we don't send data out to like a server remotely. Your eye tracking data stays local on your PC. The model that is trained for your eye tracking stays on your PC, right? It's trained all on your PC, right? All local, right? This is a huge focus because privacy is a really big issue, going forward, and also now, right? So we want to make sure that your data is yours and it stays local and no one else can have it unless you let them, right? Granted, we are not like security researchers, right? So maybe exploits and whatnot. We're not security researchers, but what we are people who are trying to be conscious about making sure that your data doesn't go out into the internet without you knowing about it. So this is kind of the focus right now.
Thank you for that answer. Let's see. We've got a question here from Voltist. For eye tracking using infrared LEDs and cameras, are there concerns of vision damage for people with light-sensitive eyes?
I mean, as long as you keep your LED power down, which I think how to do that has been like pretty well documented now. No, like I absolutely no, as long as you follow the correct guidelines and whatnot.
Yeah,
keep it below a certain
in early days,
power limit.
Yeah, early days of EyeTrackVR was really focused on safety, IR safety. So there's a lot of research that's gone into making sure that those IR LEDs are safe. If you get the V4 LED kit from the EyeTrackVR website, you should be okay. A lot of people use that kit. No one has gotten cataracts, so we know it's good. So it's good. It's good. We think it works well. It's way below the power limit specified by OSHA. It's way below the power limit I think specified by WHO. Was it? I forgot. If you go to the EyeTrackVR website, all their documentation is there on exactly what the power limits are and how to calculate them.
Wonderful. Very comprehensive answer. Question here from Skarek asking, is it possible to buy the headset-specific mounts alone for upgrading, replacements, etc.?
Hopefully.
Yeah.
We're working with PyShock, yeah?
We don't have those for sale just yet, but it is something that's like, we should probably have this up for sale as well. Just have it out there.
Lots of distribution center related things that make it difficult to sell mounts individually. We go through a distributor, like a warehouse, right? So it makes it difficult. You have to contact them. You have to do a whole lot of setup with how they're supposed to package it. We might need to make new packaging because it's just the mount, and we don't want to, give away an entire box for just a small little mount. Waste that foam and cardboard. So we're getting there. It might take some time. We're more focused on selling the full kits right now, getting data, kind of trying to improve the Babble experience in general. And then we'll go back and do these smaller quality of life things like, mounts and cameras and all these other things that we're, looking forward to.
Yeah.
All right. I've got another question here from Enstrade. What UI library is used for the Babylonia application?
This uses Babylonia, which is a cross-platform C#.NET tooling. Yeah.
All right. Got another question here from SirNate519. Are there plans for infrared or the ability to use it in the dark for face and eye tracking?
That's how it currently works.
Yeah.
That's how it currently works.
And one more question here from Staytech. When will Babble be adding nostril dilation tracking? It seems to get the rest of the face, but not the nose.
I know you.
I see you.
Maybe soon, if we're not too busy, we'll add
We
it.
ship the app, then we add the nose.
Exactly. Actually, that's not a bad idea. Get the eye tracking working with nostril dilation.
Oh gosh.
My gosh.
Pupil
That'd be
dilation
really
and
funny.
nostril dilation? Oh heck.
Yeah, but like with the eye tracking cameras, that way you could do it like on your
Learn from the
Vipro
subtle
eye.
movements of the top of your nose.
Yeah. Great.
Yeah. Let's see. I'm taking a look at the questions myself here. I think we're running short on time, but I will do my best to try.
Yeah, I think we can do one more quick question.
Yeah. Go for it.
Was there one you wanted to specifically answer?
No, I was just saying, like, I would go in and I would try and type up answers in writing there.
Well, we have, I think we're actually out of time for questions, but if you want to send things off here.
Sure thing. All right, everybody. Hey, thank you all so much for coming here, right? wouldn't be in a position to be able to make our own hardware and send it out to you guys without your incredible support and patience. As I said earlier, I'm going to try my best to go through your questions and answers. I'll be hanging around for Reality, so if you see me, stop me, ask me a question. I don't bite. And yeah, thank you all so much. Thank you.
Thanks for all coming. Thank you, guys.
Boo.
Bye.
Bye.